Students, we have derived all the three equations mathematically. We can also derive these equations graphically. So next week we will derive them graphically, but now we will see how motion can be represented graphically. So graphical representation of motion. In the drawing of graphs, the terms speed and velocity are used in the same sense because we are talking about the motion in a straight line. Okay. So distance time graph. First of all, we will study distance time graph. This is distance time graph for uniform for uniform speed. Now this is distance. This is abscissa or x-axis is time, distance is y-axis. Now as the time is increasing, the distance is also increasing gradually, and see it is a straight line. So when it is a straight line, it is known as uniform speed or constant speed. Next we can see that this, let's suppose there is some point A on the graph. We will draw perpendiculars upon this x-axis and y-axis. Let the perpendiculars be AB and AC. Now it is used to calculate the speed. Though it is a distance time graph, but it can be used to calculate the speed. We know speed is equal to distance upon time. Now distance traveled when the body reaches from O to A portion, A point. Then we have the distance traveled by it will be OC and the time taken will be OB. So speed is equal to AB upon OB. OC is equal to AB. So we can say AB upon OB is the speed. Now AB upon OB is known as the slope or gradient of the graph line OA. This you have to remember. It is known as the slope or gradient. Suppose this is a triangle ABO, right triangle. Then perpendicular upon base. AB upon OB, perpendicular upon base, is known as the slope or gradient. So we can find out speed from distance time curve by finding out the slope of the curve. Now students, this is again distance time curve, but the speed is not uniform. When this is a curve, it is not a straight line, it is not a linear line just like we have seen earlier. It is a curve. That means distance is not equal in equal intervals of time. So that means it is non-uniform speed. I have already defined in the last classes what is non-uniform speed. You can see. So this is the curve of non-uniform speed. This is distance time curve. Next we will see speed time graph or velocity time graphs. So there are three types of graphs. First is speed time graph when the speed remains constant. So suppose the speed remains constant. I just forgot to tell you that suppose this is a distance time graph. This is a distance time graph. Now if suppose this is the case, can you guess what is the speed? The speed here is 0. Speed here is 0. Why? That means the body is stationary. With the passage of time, the distance is not changing. So that means the speed is 0. So that is also a case you can study under distance time graph. Now here, this is speed time graph. Now if it is a straight line parallel to time axis, then the speed is constant. That means that with the passage of time, when the time is increasing, the speed remains constant. The speed is constant or uniform. So we can also find out, initially we found out speed with the help of distance time curve. Now we can find out distance with the help of speed time curve. Now we know what is speed. Speed is equal to distance upon time. So distance is equal to speed into time. So this is speed. Let us suppose there is some point B. We can draw perpendicular BC. Now we can see that in time OC the speed is OA. So distance traveled is OA into OC. OA into OC, or you may say BC into OC, anything you can say. So we can say that the distance traveled. Now what is OA into OC? OA into OC is, what is it? It is the area of the curve, area of the rectangle. So we can say the distance traveled can also be found out by the area enclosed by the curve or area under the curve.